So the reason I decided to make this video was that my friend sent me this image of his physics teacher explaining a concept in a manner that is a little too confusing, and I just wanted to give him a little help regarding understanding this Pulley question and how to get the tension force by two given masses. It should be an easy question, but the thing is, I saw the answer sheet, but the vector quantities and everything, the directions were very unclear, and I'm not gonna lie, it was really hard to follow. So I wanted to make this video so that my friend can view it, and at the same time, I just feel extremely meaningful to just have this opportunity to just better assist my classmates and hopefully other students who are in need of help. So let's do this. Oh yeah, and I forgot to mention, as Mr. Sal Khan, from Khan Academy always like to say, please, before you continue, try this question on your own. Alright, let's do this. First and foremost, I want to go through the first part because, the background knowledge is really important. And I was first confused because of, the negative gravity part as well. But, I would suggest you to apply something called a deductive reasoning, which is basically trying to explain a concept to a kindergartner, for example. Just try to break it down into small parts and try to understand it. So you know what a tension force is, right? Anything that pulls by a string or a rope is a tension force, such as a human pulling this dog's leash. That's a tension force. And the Newton's second law defines that every force is basically mass times acceleration, and acceleration equals to F net, which is net force, the total force divided by total mass. And because M1 and M2, in this case, two objects are interconnected by one string, so if one of the weights move, the other will also move at the same speed and acceleration. This part is really important because this acceleration, which is a constant value, helps us to better solve the equation in a more efficient manner. So here we go. We draw a free body diagram, and as you know, Newton's third law, if you push an object like that, the object pushes you at the same force. So if you draw horizontally first, you can easily tell that these are basically the same force, Fg1 and Fg2. So here, if we go to the formula, we can tell, F net equals to m total acceleration, and there's also F net equals to F1 plus F2 plus F3 plus F4, and also we can tell that F gravity is m times a, but a in this case is g, which is 9.8. So find acceleration. So F net equals to Fg1 plus Fg2, because ignoring the direction, right, this is a vector quantity, so ignoring the direction, you can tell by this formula that F net equals to the sum of individual forces. So individual forces, we're ignoring the direction for now, but we're just summing up Fg1 plus Fg2. But here we are starting to think about directions again. So, in kinematics, we apply directions to acceleration value. But in this case, we don't do that. We apply the sign directly to the force value instead of to individually doing to the acceleration. When this is plus, we have to plug in negative 9.8 here instead of just plugging in positive 9.8. If we put a negative sign here, we don't have to plug in negative 9.8. We're directly applying the vector quantity to the force instead of the acceleration. That's the confusing part. So be careful. M total, A, you get that, right? A is a constant, so the total acceleration is same as individual acceleration. The total mass is basically the mass 1 plus m2, and then m1g minus m2g, because m1 is pulling m2 because m1 is heavier, right? So this force is pulling, but this force is resisting because this is also affected by gravity, right? So we're basically subtracting m2g from m1g. And then if we move the terms, we can solve for acceleration, which is 5.88 meter per second squared. So that's the prerequisite knowledge required to understand the second part. I'm not going to deny the second part's a little more confusing, mostly because of the fact that it involves some heavy vector math, which is basically a math that talks about directions. That's everything. That's literally everything. And the thing is, the person who wrote the answer sheet is Mr. Claus, and Mr. Claus, the very guy, he really did some trick regarding directions. He didn't really clearly state the direction, and the only reason why it's confusing is because of the unclear directions. And it's okay to be confused, because as long as you understand the directions, it's going to be such an easy question. So acceleration of the string, that's the most important thing you got to remember. It's 5.88 meter per second squared down, as we derived before. And the reason is why it's down is because the general rule of thumb is that when the question is asking you to get Ft, which is a tension force, always look at the N1, the heavier one. So if you look at the heavier one, you can easily tell that the moving direction is going down. We're not looking at M2, we're exclusively looking at M1. The string is going down. So it is accelerating downwards. So it's 5.88 meter per second squared down. Next, we got to draw the FBD, which is free body diagram. So you should know that tension force works this way. And then according to Newton's third law, if you push an object this way, it's going to push back at you the opposite direction. So Ft1 equals to Ft2, but we're only looking at M1, so Ft1. So here we can tell Ft and Fg, and the F net force of M1, we're exclusively looking at the net force of only M1, not M1 plus M2, but just M1. F net force of M1 equals to tension force, right? Tension force plus what? The gravitational force, right? Because these two are pulling the other direction. The first equation, though, we're ignoring the directions. So we're just adding plus, because like plus minus, that's the territory of vector math, which is like we're dealing with directions, right? And next we gotta put this in the vector form, right? So we say F net of M1. Like what I would recommend you to do, I know Mr. Claus didn't write any, direction signs, but I would definitely recommend you to write like these signs, because it's going to help you massively, especially regarding the signs, right? So net force of M1, net force, what is net force? If it's going down, remember it's going down. Moving direction is going down, right? So if this is moving down, then what is it? It's Ft, which is like the pulley thing is holding this M1 using M2's weight, right? And this Ft is basically the force that the pulley is holding the M1 up, right? So we're just going to say Ft, which is F tension up plus M1G down. So here we also used a plus sign because we haven't converted the vector quantity to match the other variables. So M1G equals to obviously the gravitational force, right? So F tension up, M1G down. Remember that. And F net is going to be expressed in F up form because it's holding the M1 up, right? It's not holding it like this way, but tension force is basically pulling this M1 up. But the string is still going down. But nevertheless, this thing itself, like if we're only look at this part of string, it's still like holding it back from like falling onto the ground immediately, right? So although the whole thing is moving down, and it's not like immediately falling, right? So anyways, F net of M1 up equals to F tension up minus F1G up. So we converted M1G down to up by adding a negative sign. But this is where things get really confusing because Mr. Claus could have just added negative to F net M1, right? Because F net of M1 is originally a negative value. Think about it. If it's going up, like if the vector direction is up, but in reality, the whole thing is going down, right? So then if you think about it, this has to be negative, right? If the direction is up, then F net of M1 has to be a negative value, right? So will be a negative value as M1 is moving down, not up. This is not the tension force. So I'll draw the arrow again. So this is the F net of M1. So net force of M1 equals to M1 times acceleration of the string, right? And this is still going up, right? Not going up, going down in reality, but the vector direction is up. So therefore M1A is going to be a negative value because this is expressed in, up direction form. And F tension up, obviously this is, as I explained before, tension force is pulling up. So that's good, right? And M1G, right? M1G, the thing is we already converted M1G down to M1G up. So in this case, G doesn't have to be a negative sign, right? We can't put it in, we cannot put negative sign to the G because that's, if it's negative, if we plug in negative 9.8 to G, then this is going to change to a positive value, which doesn't make sense because, gravity is pulling down. And we already converted in this stage. If we don't convert it, right, then it's going to be right to apply negative sign to 9.8. But weirdly, Mr. Claus applied a negative sign, converted the vector quantity in this step instead of doing it in this step, which is going to be more, easier to understand for students, right? But negative sign, we already applied negative sign, so we don't apply negative sign to 9.8. This is not, this is weird, I know, because, he kind of messed up the steps, but anyways, yeah, we don't apply negative to G. But here, funnily enough, we do apply negative sign to A, because the thing is, as I told you before, the whole thing is moving down, and this is the net force, right? M1's net force, not the whole thing, just the M1. But the net force has to be going down, but this is expressed in the up term. So in this case, we gotta apply negative sign to 5.88, which is the acceleration of a string. So it's gonna be M1 times negative 5.88, whereas here it's just 9.8. It's not negative 9.8 because, funny thing, We converted M1G down to M1G up here. We haven't converted this, this is supposed to be down, and then we haven't converted this to up. Like, the proper way, honestly, not I'm not saying Mr. Claus's way is wrong, but a better way to just explain this would be like that, right? And then up, and then adding a negative sign right there. And then in this step, we don't have, like if there's a negative sign here, we don't have to put a negative sign in front of 5.88. So it's consistent, right? The steps we took here and the steps we took here, which is also like converting here, it would be consistent, right? But we're not being consistent because, I don't know, that's just what Mr. Claus did on his answer sheet. So yeah, so okay, I'll fix that again. Right, so we add a negative value to acceleration and the net force, but we don't add a negative value in the gravitational acceleration because we already converted in the prior step. But we haven't converted this one, which is like, I don't know. So yeah, that's the reason why it's so freaking weird. You don't have to, like, I would definitely suggest you to just write this in down, like a down form, and then convert it, like adding a negative sign here. But man, I don't know, Mr. Claus, bro, like, I don't know. But yeah, that was it.